Okay, gang, this is going to look a little weird at first. So the derivative of the natural log is 1 over x. The derivative of the composite natural log is 1 over the inside times the derivative of the inside. So now let me say it again, because maybe my language might help you get it, understand the concept. So the derivative of ln of x is 1 over the inside. The derivative of the composite ln is 1 over the inside times the derivative of the inside. Because once it's a composite, it has more than one layer, and you have to take the derivative of each layer. Okay? Let's try a couple of these. Let's see how it goes. Alright, this is your plain ln of x. This is not a composite. So y prime is going to equal to 1 over the inside. So the derivative of ln is 1 over the inside. And one of the reasons too why I'm trying to stress these is when you go into Calc 2, you do this in reverse. Like you start with this and you go to that. Alright, now this one just has a multiplier on it. So when you take the derivative, just like before, the 2 just carries along. So the derivative of ln of x is 1 over x. And it's just getting multiplied by a 2. So right away, if you write 2 over x, that would be correct. Alright, now this is the first composite we hit, because the first two were not composites. That one was just the straight up basic kind. This one had a multiplier out front. Now this is a composite because anything other than an x in the inside makes it a composite. Alright, so here's how you go about it. The derivative of ln, you want to think about the derivative of ln as 1 over the inside. So 1 over the inside. Okay, now you want to take the derivative of the inside. So derivative of 2x is 2. And then when you simplify it, it's 1 over x. And for some reason, I feel like some of you are thinking, well, can we use our properties, log properties? You can, right? If you use your log properties, ln of 2 plus ln of x. ln of 2 is a constant, so that goes to 0. ln of x is 1 over x. So you get the same answer if you did that, if you used your properties. Alright, now this log is a composite, but also there's a variable times a variable. So there's the product rule as well. So overall, you guys need to think product rule, but it does have a subset of chain. Okay, overall we're going to do product rule with a subset of chain. Here we go. Let's give it a go. So first, oh, and I hear some of you now asking me, can we use our log properties on this one? Absolutely. The log properties actually make this one easier, so I would actually suggest doing it. But let me just do it the way it is here so I can show the rules. Yeah, see, that's the thing with you guys. You start to outsmart me after a while. I can't keep up with you. All right, so we're now taking the derivative of ln. So the derivative of ln itself is 1 over the inside. So it's 1 over x to the 3/2. And then it's times the derivative of the inside. So derivative of the inside, you'd have to use the power rule for this. So 3/2 x, then you have to subtract 1, so it'd be 1/2. Okay, so first times derivative of second plus second times derivative of first. Derivative of x is 1. Woo! This is messy. I'm just trying to figure out the nicest way to say it. I think the nicest way to say it is, let me bring the 3/2 to the front. Both these x's are on top. So you've got one whole pizza here, 1/2 of a pizza on top. So altogether on top you've got 3/2 of a pizza. 1 whole and a half is 1 1/2. This guy's on the bottom. Ooh, you can probably see what's going to happen there. Let's just go ahead and fiddle with that while we're at it. So this is actually going to cancel. You're just left with 3/2 because it's going to reduce. And over here is a 3 over 2. And I would just leave it like that. I wouldn't bother to fiddle with that much more. Actually, let me take that back. I think it's nicer actually if you do maybe this. Like get an LCD, but I don't know. It doesn't. This is okay too. That looks better, but it's not that big of a difference. All right, let's eyeball this one. Now this is a composite. because there's something stuffed in the log function. So the derivative of the outer layer is 1 over the inside times now the derivative of the inside. The derivative of the inside is derivative of this. So altogether that would look like and really if you get this right away, you can just go ahead and go right to this. You don't really need to do this step. You know that this is on the bottom and the derivative of the inside is on the top. Alright gang, let me leave it here for this one. So this is your log. This is your log and your composite log. I'll pick up in another video with other bases. Okay, catch you gang. Bye.